This video is about determining the area of a triangle, determining the area of parallelograms, and applying the area of triangles and parallelograms to composite figures and shaded regions. So as a reminder, the standard unit for any time that we are doing area is going to be units squared. So it can be centimeters squared, it can be feet squared, it can be inches squared. The area is the closed region in the number of square units within the boundary of a region. So let's look at two shapes that we probably know how to find the area of already. We have a rectangle and a square. So to find the area of your rectangle, we're going to do base times height. Remember that we need to have the perpendicular sides in our rectangle. So we have our height and our base. A square then, remember that a square has 4 congruent sides. So once we know the side length of one side of the square, we can just multiply it by itself to get the area of the square. So let's use these two formulas to find our area. Number one, find the area of a square. So in this case, it's a square with our diagonal drawn in. Remember that when we have a diagonal drawn into a square, it creates our 45, 45, 90 triangle. So the sides of our triangle are going to be L. The diagonal is going to be L root 2. So we need to solve for L. We can divide by root 2. So 12 divided by root 2, because nothing reduces, we need to rationalize by multiplying with the fraction of root 2 over root 2. So we get 12 root 2 over 2, and that reduces to 6 root 2. So that means the sides of our square are 6 root 2. So to get the area, we can do 6 root 2 squared, which is really 6 root 2 times 6 root 2. You can put them in your calculator either. If you put this in your calculator with the squared, make sure you put parentheses around it, and we get the area then is going to be 72 centimeters squared. Make sure that you always include your units in your final answer. Number two, find the area of the rectangle. So in a rectangle, we know we have right angles at our corners. We already know that one of the angles formed by the diagonal is 30, which means the other angle has to be 60. So this is creating a special right triangle. So across from the 30 is the S, across from the 60 is the S root 3, and across from the 90 is our 2S. So we can use that to find the length, the base length, and the height. So we know that 40 needs to divide by 2 to get 20. So we have one side is 20, and the other side then is 20 root 3. To get our area, we are doing base 20 root 3 times the height of 20, which would simplify to 400 root 3 meters squared. So now we're going to move to a parallelogram. So the area of a parallelogram is the same formula as a rectangle. It's still base times height. The thing we have to remember in a parallelogram is that our sides are not always going to be perpendicular. So we might have to draw a height in to be perpendicular to the base. So let's look at a few problems. In number 3, we have our base is 15. We have the other side is 11, but we don't have the height yet. So what we're going to do is we're going to draw in a height that makes it perpendicular. So now we want to focus on this triangle. So if I'm using that triangle, I know that I have the opposite and the hypotenuse. So I'm going to use sine to find the height of the parallelogram. So we have the sine of 67 is equal to x over 11. So we have 11 times the sine of 67 equals x. When we round to 3 decimal places, we get 10.126. So our height then is 10.126. Our base is 15. So to get the area, we would do 15 times 10.126. And we get our area is equal to 151.89 centimeters squared. In number 2, we also don't have our height, but we have a triangle that is drawn outside the parallelogram. Now, even though it is not inside the parallelogram, the height can still be found. So in this case, we know that the opposite side is 20. So we have two sides of our triangle. If we don't have an angle measurement, that means we have to use Pythagorean theorem. So 20 squared is equal to 12 squared plus x squared. So we get 400 equals 144 plus x squared. 256 is equal to x squared, so x is 16, which means the height of our parallelogram is going to be 16. So our area is the base, and we only want this as the base. The 12 is not included because it's a dotted line. So we have 38 times 16. So our area is going to equal 608 meters squared. In number 5, we also do not have our height, so we can draw the height in over by the 60-degree angle. The opposite sides of the parallelogram are congruent, so our opposite side's 24. This creates, in our triangle here, a 30, 60, 90 triangle. So we know that this side is 2s, the bottom is s, and the height is s root 3. So if we do 24 divided by 2, we get that s is 12. So our height is going to be 12 root 3. For the base, we want to use this whole number 21. So our area is 21 times 12 root 3, which equals 252 root 3 meters squared. Our next shape is finding the area of a triangle. So for any triangle, we can always find the area by doing 1/2 base times height, where the height is perpendicular to the base. If we have a special triangle, an equilateral triangle, which is a triangle with 3 congruent sides, then our area, we can use the formula of root 3 over 4 times s squared, where s represents the side length. So in number 6, find the area of the triangle. So our height is 9. This whole side on the bottom here is going to be our base, so we have to add 6 and 16 together to get 22. So to find the area, it is 1/2 base times height, so that is going to equal 99 feet squared. In number 7, the base of an isosceles triangle is 18. If both legs are 41 centimeters, what is the area of the triangle? So in an isosceles triangle, remember that you have 2 congruent legs and a base. So the base is 18. The congruent legs are 41 and 41. Now, we don't have a height to our isosceles triangle yet. So we can draw in the height, which splits the base into 9 and 9. If we focus on just half of our triangle, we can use Pythagorean theorem to find the height. So we have 41 squared equals 9 squared plus x squared. 1681 equals 81 plus x squared. 1600 is equal to x squared. So x is 40. So now that we know our height is 40 and our base is 18, we can find the area. So our area is equal to 1/2 the whole base, which is 18, times the height, which is 40. So we get that our area is 360 centimeters squared. In number 8, an equilateral triangle has a perimeter of 24 feet. Find the area of the base. So if we know that we have an equilateral triangle, we have a special formula for that. So the area of our equilateral triangle is root 3 over 4 times the side squared. So we need to know what the side is first. If the perimeter is 24, we have 3 congruent sides, so 24 divided by 8 will get us our side length. All right, 24 divided by 3, which will get us 8. So our side length is 8, so the area is root 3 over 4 times 8 squared. So in your calculator, do not put the root 3, so you can just do 8 squared, which is 64, divided by the 4, the denominator, and we get 16 root 3 feet squared. Number 9, find the area of the triangle. Hint, draw a height outside of the triangle. So right now we don't have a height, so I'm going to draw this outside the triangle that is perpendicular to the base. If the angle inside the triangle is 113, outside the triangle is 67, so we can use that to find our height. So we have our opposite and our hypotenuse, so we're using the sine of x, the sine of 67 is equal to x over 13. We can multiply 13 times the sine of 67 is equal to x. So we get x equals 11.9 7. Now that we know our height, our base is going to just be what was part of the triangle, so the 10. So our area is equal to 1/2 10 times 11.967. So we get our area is 59.835 feet squared. In number 10, an equilateral triangle has an area of 30√3 feet squared. Find the side length. So we know that the area of an equilateral triangle is equal to √3/4 times the side squared. And we know our area right now is 30√3. So to get rid of that fraction in front of the s squared, we can multiply by the reciprocal. So we can multiply by 4/√3. The √3s are going to cancel out, and we're left with 4 times 30, which is 120. So we have 120 equals s squared. So to get s, we would need to take the square root of 120 and simplify. So that simplifies then to 2√30. So our side length is going to be 2√30 feet. Next, we have composite figures. So a composite figure are a shape or multiple shapes that are put together in order to create a bigger one. So in this case, we have a hexagon and a rectangle together. So if we split them up using this line right here, we would have a hexagon and a rectangle. So let's look at finding the area of a composite figure. So in number 11, we have what looks like a rectangle with another rectangle and a triangle. So we want to find the area of that. So first I'm going to do is I'm going to split this rectangle into 2 rectangles. So we have one rectangle that is 12 by 7. And we have one rectangle that is 5 by 4. Then we also have this triangle, which is an isosceles triangle. Now, because we have these two sides, 7 and 5, they're going to represent the length of the base of the triangle. So the base of the triangle is going to be 12. But we don't know the height yet, so we are going to draw that in, which splits the base into 6 and 6. So we can do Pythagorean theorem to find the height of the triangle. 10 squared equals 6 squared plus x squared. 100 equals 36 plus x squared. 64 is equal to x squared, so our height would be 8. So now we can find our area with the 3 different pieces. So we have the 2 rectangles. One rectangle is 12 times 7, plus we have one rectangle that is 5 times 4, plus we have our triangle, which is 1/2. Now, remember the base is the whole side, not what we split it into to find the height. So our base is 12, and the height of the triangle is 8. So we can find the area of each of those pieces. So 12 times 7 is 84, plus 5 times 4 is 20, plus 1/2 times 12 times 8 is 48. Because those are all just constant numbers, we can add them together. And we get our area then is 152 centimeters squared. Number 12, we have what looks like a hexagon that has been split into 2 triangles and a rectangle. So we know that all of these sides have to be 6 because they all have this same congruency mark. Now, on the top, we have, again, we have a triangle here. Now, we have a special right triangle in this case because it's a hexagon. So remember from our hexagon formulas, we can find what this whole angle is. So each angle inside a hexagon, we're going to do the number of sides minus 2 times 180 divided by the number of sides. So that gets us 120 degrees. If we draw in our height, though, that splits it into 60 and 60. So we now have a special right triangle. So if we have a special right triangle, we know that this is our 2s side, this is our s, this is our s√3. So if 2s is equal to 6, we can divide. We know s is 3, so our other side is 3√3. If both of these are 3 root 3, that makes this whole side 6 root 3. So now we can find the area. So in this case, our area, we have two triangles. So 2 times 1/2 times the base, which is 6 root 3, times the height, which is 3, plus the area of the rectangle, which is 6 times 6 root 3. So in this case, when we multiply then, 2 times 1/2 times 6 times 3 gets us 18 root 3 for the both triangles, and then 6 times 6 is 36 root 3. So when we add those together, because they both have a root 3, we are left with 54 root 3 centimeters squared. The last problems that we're going to look at then are shaded regions. So shaded regions are only part of the picture that we want to find the area for. So in order to do that, we need to find the area of the biggest figure and then subtract out the parts that are not shaded. So in number 13, our largest shape is a triangle. And if we look at that triangle, we see that the height of the triangle is 10 because it's 3 plus 7, and the base is 16. But we have to also subtract out the 3 white pieces. So if this part is 5, this base of the triangle is 5, and if this part is 3, the height of the other triangle is 3. So now we can do our area. So we're going to do the area of the largest triangle. You always want the biggest shape first. So we have 1/2 times 10 times 16. Now, unlike a composite figure, we're going to subtract out the parts that are not shaded. So first we have this triangle up top that has the dimensions of a base of 5 and a height of 7. So 1/2 times 7 times 5 minus our rectangle, which is 3 times 5, minus our other triangle, which is 1/2 times 11 times 3. So we're going to do each of these areas separately. So we have 80 minus 17.5 minus 15 minus 16.5. So when we subtract from 80 the 3 parts that are not shaded, we get our area is 31 millimeters squared. In 14, we have a rectangle and we have a triangle. Now, in this case, if I draw the height of my triangle in, it's the height of the rectangle. So our height is 6. So we can find the area of the rectangle, 6 times 21, minus the area of the triangle, which is 1/2 times 6 times 21. So that gets us 126 minus 63. So the area of the shaded region is 63 feet squared.